Hi everyone. Today we are going to learn simultaneous equations by the method of multipliers. By choosing proper functions p1, q1, r1 of xyz, which are functions of xyz, we can write the standard form of simultaneous equations dx by p equal to dy by q equal to dz by r in the form of p1 dx plus q1 dy plus r1 dz whole divided by p1p plus q1q plus r1z. That is, we have to multiply these multipliers that we are choosing in the numerator as well as in the respective terms of the denominator and add them. If p1, q1, r1 are such that the denominator term, that is p1p plus q1q plus r1r equal to 0, then p1q p1 dx plus q1 dy plus r1 dz equal to 0. That is, the numerator will be equal to 0. Then we have to integrate this function and find the first part of the complete solution, which will give us u1 of xyz equal to c1. Again, we have to find another set of multipliers to get another pair of solution, that is p2 q2 r2, so that the denominator of this function with respect to p2 q2 r2 will now become p2p plus q2q plus r2r equal to 0, such that the numerator term then will be p2 dx plus q2 dy plus r2 dz equal to 0. We can obtain by solving this equation, that is by integrating another part of the complete solution in the form of u2 of xyz equal to c2, and these two solutions together form the complete solution. These functions p1 q1 or p2 q2 r2 are called multipliers. Now let us solve a problem by the method of choosing multipliers. Solve dx by x into y minus z equal to dy by y into z minus x equal to dz by z into x minus y. By inspection, choose 1, 1, 1 as multipliers, because we know that xy, we have x into y here, that is xy, and in this term y into x becomes minus xy. So xy and minus xy will get cancelled. It becomes 0. Similarly, the other terms also get cancelled. Therefore, we are choosing 1, 1, 1 as the multipliers. Now each fraction now becomes 1 into dx plus 1 into dy plus 1 into dz equal to 1 into x into y minus z plus 1 into y into z minus x plus 1 into z into x minus y. Now by solving this, we'll get dx plus dy plus dz whole divided by xy minus xz plus yz minus xy, that is by removing the brackets, and the last term will now be plus zx minus zy. This way xy minus xy, yz minus zy minus xz plus zx gets cancelled and it leaves a 0. Therefore, the numerator is now equal to 0. By the working rule of simultaneous equations, we will now get dx plus dy plus dz equal to 0. Integrate this function, it will give us x plus y plus z equal to c1, which is the constant of integration. So that is one part of the complete solution. Now we have to proceed to find another part of the complete solution. Hence, again using 1 by x, 1 by y, 1 by z as multipliers. Now we will get 1 by x into dx plus 1 by y into dy plus 1 by z into dz. Okay, whole divided by 1 by x into y minus z plus y 1 by y into z minus x plus 1 by z into x minus y. So these terms x, y, z, they divide each other and leaves us 1. And by removing the brackets in the denominator, now gives us y minus z plus z minus x plus x minus y. Okay, and the numerator is written as it is. The denominator terms get cancelled. It leaves a 0. Now the numerator is equal to 0. That is 1 by x dx plus 1 by y dy plus 1 by z dz equal to 0. Integrate on both sides. That gives us log x plus log y plus log z equal to a constant. Constant is also taken in form of log since the left hand side is log. And we know by the properties of logarithm that we will get log x plus log y plus log z equal to log xyz equal to log c2, and log gets cancelled on both sides, and that gives us xyz equal to c2. Hence the complete solution is x plus y plus z equal to c1 and xyz equal to c2. Now to proceed with, if we take another problem, solve dx by mz minus ny equal to dy by nx minus lz equal to dz by ly minus mx. Now we have to choose multipliers such that the denominator terms get cancelled and it leaves a 0. Therefore, accordingly, we see that we have mz here and here we have lz in the second term. So here when we compare these two terms, here L is missing, here M is missing. Therefore, we will choose the multipliers as LM and the last one will be N, LMN. Choosing the multipliers LMN, we will then get from equation 1, from the given equation, L dx plus M dy plus N dz whole divided by L into mz minus ny plus M into nx minus lz plus N into ly minus mx. Remove the brackets in the denominator. That leaves us with lmz minus lny minus mnx minus lmz plus nly minus mnx. So that way lmz minus lmz gets cancelled, minus lny plus nly gets cancelled, and mnx minus mnx also gets cancelled, leaving a 0 in the denominator. Hence the next step, L dx plus M dy plus N dz is equal to 0. On integrating, we will get Lx plus My plus Nz equal to C1. Now, that is one part of the complete solution. We have to choose another set of multipliers. Hence, we choose x, y, z as multipliers, and that gives us x dx plus y dy plus z dz whole divided by m x mz minus xny plus ynx minus ylz plus zly minus zmx, and the terms get cancelled. Xmz minus zmx, which is as good as xmz, so it gets cancelled, it becomes a 0. Minus xny plus ynx becomes 0. Minus ylz plus zly becomes 0. Thereby, it leaves a 0 in the denominator of the whole fraction. It leads to x dx plus y dy plus z dx equal dz equal to 0. On integrating, we get x square by 2 plus y square by 2 plus z square by 2 equal to c. Taking the LCM and multiplying by 2 on both sides, we will get x square plus y square plus z square equal to 2c. 2c is now written as c2, which gives us, and this step gives us the second part of the complete solution. Thereby, complete solution is Lx plus my plus nz equal to c1 and x square plus y square plus z square equal to c2. Thank you.